I can solve a Rubik's Cube, but I'm not too good at it. What I am good at, though, is math. That's the entire point of this channel. Believe it or not, the Rubik's Cube has more than 43 quintillion possible combinations. That's 43 followed by 18 zeros, and it's more than the grains of sand on Earth. So, how did we arrive at this final result? Well, let's take a deep dive into it. A classic 3x3 Rubik's Cube has 8 corner pieces. Let's take a look at how many different ways each corner can be placed. The first corner has 8 different slots it can go into, since there are no other corner pieces in just yet. The second corner piece now has 7 slots it can go into, since one corner is always going to be taken up by the first piece we placed. Similarly, the third piece has 6 slots that it can go into, because the first 2 pieces already took up 2 slots. This goes on and on until we have only one piece that has 1 slot that it can go into. Multiplying all the consecutive natural numbers from 1 to 8 is represented as 8 factorial, or 8 followed by an exclamation mark. Let's take a look at the edge pieces now. There are 12 edge pieces in a 3x3. If we repeat this same process of taking a look at the available slots for each of the edge pieces, we get 12 factorial. Feel free to work that out on your own. But the key thing is, we still haven't taken a look at how each of these pieces can be placed in different orientations. Suppose we take out a corner piece. It can be rotated this way, and this way. Since each corner piece can be rotated 3 different ways, 8 corner pieces can be rotated 3 to the 8th ways. But here's the catch. The last corner piece cannot be rotated on its own, since, as every cuber knows, it is impossible to solve a cube that way. So essentially, the last corner is determined by the other 7 corners, leaving us with the final answer of the corner piece's orientation being 3 to the 7th orientations. Now, let's do the same thing for the edge pieces. The edge pieces can be oriented 2 different ways. There are 12 different edge pieces, so that gives us 2 to the 12th different orientations. But remember, only one edge being flipped is not valid. So the last edge is determined by the other 11. So we get 2 to the 11th ways. Finally, because all of the parity cases, only half the permutations actually give you a solvable cube. The others don't. So we divide everything by 2. This gives you this equation, the final equation, and this is equal to 43 quintillion possible combinations. Also, if you like cubing, be sure to check out Cubing with Andy's channel. He's a great cuber, much better than me, with funny and informative videos. With that being said, I'll see you guys in the next one.